We want to take a few minutes in this video to address one aspect or an aspect of the transition from basic math to algebra that we think is important and perhaps doesn't get enough consideration in the classrooms. And that really is the question as to why. Why is this even important? That is to say, why is the algebra making this transition from basic math to algebra? Why do it? Why do it at all? We again, as in previous videos, we're going to talk briefly and remind students that as far as the basic math is concerned, we expect that you have mastered the various functions, operations in mathematics. That is to say that you can add, subtract, multiply, and divide real numbers really, really well. And by real numbers, again, we depict real numbers by the numbers on the number line. Any numbers that can be represented by values on the number line are considered real numbers. And we know, of course, that those includes fractions, decimals, percents, and also rational and irrational numbers. In terms of classifications, we talked about those in previous videos. So here's the deal. So now you've mastered these operations. You can do it on any number on the number line and different types of numbers on the number line, all the real numbers. You're really, really good at those operations. Okay, all real numbers. But here's the thing. In order to demonstrate that skill, your instructor would have to have given you a number of problems. Let's say 3 plus 4. You did some addition problems, and you did a whole lot of problems with fractions. You can do mixed numbers and all of those. Okay. You've done your work. You've put in the time and the dedication that was necessary to learn all of the various skills in terms of how to operate on a whole host of different values, whether it's mixed numbers, fractions, decimals, percent. You've done the work. Okay. But here's the thing. All of these problems that we just did are very specific problems. They're very specific. That is to say, they're asking you to do a particular operation, whether it's adding, subtracting, multiplying. In this case, you need to know what has to be done in order to get this answer, changing it to a decimal and multiplying and so forth and on. But at some point in mathematics, and it is at this point, we want to be able to go from the specific to the general case, to the general rule. And that's where the algebra comes into play. We want to go to the general rule and having to do with these operations. Therefore, your algebra instructor, in algebra, rather than giving you a problem of this sort, a specific problem, your instructor wants you to recognize that this problem can be represented this way. So x minus y. And now you notice that the focus is more on the operation than the particular values, because these values can vary, they can change, and without being too coy about it, that's why we call these guys variables, of course. So we don't want you to worry about the particular values. We want you to now start thinking about the general rule. Start focusing on the concept, the general rule, or the concept. Okay, the big picture, if you will. Because in order to give you a whole host of problems in basic math, that would take a lot of time, a lot of space. So by doing it this way, we're going to speak to the two issues having to do with algebra. Two very important components to algebra, and the first of which is that we want mathematics to be efficient. And the other thing we want to do in mathematics is we want to be clear. Okay. So in terms of efficiency, it is really not to our it really does not help us to go ahead and list 100 problems when once you understand the concept of subtraction, this will do such quite well. And therefore, in order to generate a whole host of problems, all you need to do is to assign values to x and y. And of course, those values will come from your number line. Okay. So this gives us the luxury of now being able to focus on the concept. So the efficiency aspect, we're only going to talk about this part only, is by representing expressions this way and letting you know that these elements, these values, have to come from the real number line. All right. That means that this representation is now covering a whole host of problems without having to list 100 problems out as you would have to do in basic math. So therefore, if you're told, and these values x and now are assigned values from the number line, okay, so you're going to say that x is, and it doesn't have to be nice numbers at this point, because remember, you're very, very proficient at basic math. And in fact, you've excelled in basic math and you're ready to take that next step. So we're going to give you x is 3.5 and y is going to be for us 1 3/5 or something. Not only that, it could be 1 3/5%. Let's make it really interesting. Because what we are taking off the table now, when you make that transition from basic math to algebra, we're taking these skills off the table. Because at this point in time, we want to now worry about concept, making us more skillful at the bigger picture. We're addressing the bigger picture, if you will. And that's what algebra is all about. Algebra is now an attempt to focus on the concept and not the specific problems, the general rule, as we said earlier. Okay? And at this point, we're going to conclude this presentation because what we're trying to say to you as young students entering into algebra is you're being able to do this problem, you're being able to substitute it in and to solve this is not our concern. But having thought about that, I'm going to go ahead and do it because I think I don't want to, it would be helpful not to leave you wondering or guessing as to what would be done, and we can conclude on a nice note to say that x minus y is the expression that we have to evaluate. And of course we know we have to substitute. Our 3.5 goes here, minus our y value is 1 3/5%. Your basic math skills tells you that you might want to get these values in the same form, and therefore we're going to convert this 3.5 to 3.5. We're going to subtract from that. Now this one is a percent with a mixed number. Let's go ahead and change this to an improper fraction first. This will be 8/5. 5 times 1 plus the 3, that's where we got our 8 from. And then the 5, the denominator is 5, but it's still a percent. So now we have a fraction, a percent. It looks messy, but again, we're in basic math mode. We know our skills. 0.5. Let's go back. 3.5 minus. Now we're going to get rid of the percent by moving this 2 places to the left. This becomes 0.016. And we're almost there. We're going to go ahead and subtract now. So 3.5 minus 1.016. Let's see, make sure we keep everything lined up. We're going to have to borrow, which will give us a 4. That's going to give us a 3 here. And finally, 3.34 is our final answer. Okay, so let's check that again. That becomes 50. 50 minus 34. Is that right? No, that's not correct. Let's go back. Let's we lost our place there. Let's go back. Okay, here we go. So we need 2 zeros here, so it's going to have a 4 in this place. That becomes a 9. That's an 8, 4, and 4 here. Alright, that's better. 3.484. But again, that's clearly a demonstration where the basic math skills have to come into play here, and that has been mastered. So our main focus was on the concept, and there you have it. Alright, so we hope this helps. Be careful with your math, and we'll see you on the next video. Take care.